Hey fellow problem solvers, today I'm going to go over systems of quadratics and how to solve. If I have two pretty complex quadratics that are both conics, how I'd solve them. The first one is 9x squared plus 32y squared equals 324. I notice both an x squared and a y squared term, so I recognize it as an ellipse. And then the second equation in red here is 3x squared minus y squared is equal to 3. I recognize that as a hyperbola. If I graphed them, I could see there's probably 4 points of intersection. I'm going to do this like I do it in linear equations. I'm just going to combine the two and see if I get a term to drop out. I have a 9x squared and 3x squared. I think I'm going to multiply both sides of this equation by a negative 3 and then rewrite it down here. So that's going to be negative 9x squared. Negative 3 times negative is positive 3y squared, and that's going to be equal to negative 9. I'm going to combine those two equations, and the x squareds are going to drop out, giving me 35y squared is equal to 3. I divide both sides by 35, and I get y squared is equal to 9. So then the square root of both sides is going to be y is equal to 3 or negative 3. A lot of times in Pythagorean theorem you discard the negative, but here you're going to have two solutions because the square root of 9, 3 times 3 is 9, or negative 3 times negative 3 is 9. So if y is equal to 3, I'm going to take that and plug it back into this equation here, right up here. 3x squared minus 3 squared is equal to 3. Add 9 to both sides. 3x squared is equal to 12. X squared is equal to, divide both sides by 3, 4. X is equal to plus or minus 2. Okay, I redrew this so there's a little bit more room. Again, I had that y is equal to 3. I plugged it in there. And then I solved for x, and I got x is equal to 2 or negative 2. So when y is 3, x, the first term could be 2. So there's a solution. Or when y is 3, another possible solution is negative 2. So there's those solutions. My other two values of y were y equals negative 3. So I'm going to take that negative 3 and plug it into that first equation. So I have 3x squared minus negative 3 squared. Write that minus out front. I'm not squaring the whole thing. So negative 3 squared is 9 equal to 3. I'm going to add 9 to both sides to get 3x squared is equal to 12. Divide both sides by 3. X squared is equal to 4. Square root of both sides. X is equal to positive 2 or negative 2. And then I have a y value of negative 3. So another solution could be that positive 2x and that negative 3y, or that negative 2x with that negative 3y. So there are 4 coordinates of intersection, or 4 points of intersection. They're all coordinates. And where those would be on the graph is this one right here. Over 2 up 3 would be right there. This one right here would be over 2 down negative 3. Over negative 2, down negative 3, over negative 2, up positive 3. So that hyperbola and ellipse would cross in 4 places, and that's how you would algebraically solve for them, and then graphically that's what it would look like. Not my finest artwork, but that'll give you an idea of how to solve a system of equations. If you can't combine them with linear combinations and have them drop out because there's a singular x term and a singular y term, then you're going to have to use substitution, and I'll make another video of how you would solve these with substitution. If you have any questions, please post them in the comments. Thank you for watching.